Almost everything you've been told about the most famous experiment in physics is wrong. You've probably heard the story yourself. You fire the tiniest specks of matter, one at a time, at a wall with two narrow slits in it, and when nobody is watching which slit they take, they spread out like waves and build a striped pattern on the screen behind, as if each speck went through both slits at once. But the instant you watch which way they go, the story says they panic. They stop behaving like waves, snap into little bullets, and collapse into two neat piles. Reality itself, the story promises, changes the moment you look at it. It is a beautiful idea, repeated by teachers, by textbooks, and by famous physicists for decades. And it is a lie, because those two neat piles never appear. When you truly watch, the universe does something far stranger, something almost no one ever tells you. So what really happens when you look? Tonight, by the end, you will know exactly. Get comfortable and settle in. Subscribe if you have not and stay with us, because to understand what the watched particles really do, you first have to see what a single electron does when nobody's looking at all. Let's get into it. Part 1. The Lie. Everyone tells. There is a lie about the double slit experiment, and almost everyone who has ever told you about that experiment has told you the lie. Teachers tell it, textbooks print it, documentaries dramatize it with slow music and a hushed voice. Famous physicists, people who have spent their whole lives inside the mathematics, repeat it in interviews without blinking, and the person speaking to you right now believed it too for years and told it to other people with complete confidence, because it is such a beautiful and satisfying story that it feels like it has to be true. The lie goes like this. You take the smallest things we know how to handle, individual electrons, and you fire them one at a time at a barrier with two narrow slits cut into it, and behind that barrier you put a screen that lights up wherever an electron lands. If you do not watch which of the two slits each electron goes through, the electrons build up a striped pattern on the screen, a pattern of bright bands and dark bands, exactly as if each electron were a wave that passed through both slits at once and rippled out the other side. But then, the story continues, the moment you place a detector at the slits and actually watch which way each electron goes, everything changes. Now that they are being observed, the electrons supposedly stop behaving like waves. They snap into behaving like ordinary particles, like tiny bullets, travelling in straight lines through one slit or the other, and piling up in two neat clumps on the screen, one clump behind each slit. The stripes vanish. The bullets return. You can feel why this story spread the way it did. It hands you one of the most intoxicating ideas a person can hold, which is that reality itself changes depending on whether it is being watched. It says the universe behaves one way when no one is looking, and another way the instant an eye or a camera or a mind turns toward it. It puts you, the observer, at the very center of the cosmos, with the power to collapse possibility into solid fact just by paying attention. People have built entire philosophies on that idea. They have built entire pseudosciences on it, whole shelves of books promising that if observation shapes reality, then your thoughts can shape your life, your health, your fortune. The story is a doorway that a lot of people have walked through, and on the other side of it is the comforting feeling that looking is a kind of magic. And I want to be fair to everyone who has ever told it, because I was one of them, and the people who tell it are not liars in the ordinary sense. They are not trying to deceive you. They believe it themselves sincerely, most of them, and they tell it because it is the version they were told, by someone who was told it by someone else, going back and back through a long chain of well-meaning teachers and writers and narrators, each one passing along the tidy story, because the tidy story is the one that fits in a single breath. That is how this particular era survives. It is not a conspiracy. It is something more like a piece of folklore, a rumour that got repeated so many times, in so many trusted voices, that it hardened into something that feels like established fact. It is, I think, the most widely believed wrong answer in all of popular science, and the reason it is so widely believed is precisely that it is told by people who should know better, and who genuinely think they do. So when I call it a lie, I do not mean that anyone set out to fool you. I mean that a false thing has been repeated so often and so confidently that it has taken on a life of its own, a life that no longer depends on anyone actually checking it against the experiment, and tonight we are going to check it. Here is the problem. That story is wrong. and it is not wrong in some small, technical footnote way that only a specialist would care about. It is wrong in a way that flatly contradicts what the experiment actually shows when you go and do it. When you watch which slit the electrons go through, they do not form two neat clumps. They never have. What they actually form is something else entirely, something that is still, unmistakably, the behavior of a wave. The two clumps that every explanation promises you, the two little piles of particles that supposedly prove that observation turned the waves into bullets, do not appear. They are a ghost. They are the single most confidently predicted result in all of popular physics, drawn on 1,000 whiteboards, and nobody has ever actually produced them with a real experiment, because the universe does not do what the story says it does. So if that is the lie, what is the truth? That is the whole of tonight's journey, and the honest answer is stranger and, in a quiet way, far more beautiful than the story it replaces. The real lesson of the double-slit experiment is not that watching turns waves into particles. The real lesson is that the things we call particles and the things we call waves are the same kind of thing wearing two different disguises. It is that an electron, which you were taught is a tiny piece of solid matter, and a beam of light, which you were taught is a wave rippling through space, behave in exactly the same way when you send them through those two slits. Not similarly, identically. And if the little bit of matter and the ripple of light do exactly the same thing, then maybe neither of them is really a particle, and neither of them is really a wave, and the words we have been using our whole lives were never big enough to hold what is actually there. To get to that, though, there is no shortcut. You cannot simply be told the answer and feel it, because the answer runs against everything your body knows about how objects behave. You have to walk into the experiment the way the physicists walked into it, one careful step at a time, and let each step take a little more of the ground out from under you. You have to first understand what a genuine wave does, and then what a genuine particle would do, so that you know exactly what you're looking at when the electrons refuse to do either. You have to sit with the strange fact of a single electron, alone in the apparatus, somehow going through two slits at once. And then you have to walk right up to the moment everyone gets wrong, the moment you turn on the detectors and watch, and you have to watch, with your own eyes, what the universe actually puts on that screen. Because here is the thing that the lie steals from you, and that the truth gives back. The lie makes the universe into a performer, something that behaves one way for an audience and another way in an empty room, as if it were shy, or as if it cared whether you were there. The truth is stranger and, I think, more comforting. The truth is that the universe is doing the same profound, impossible-seeming thing, whether or not anyone is watching, whether or not anyone has ever watched, whether or not there are any eyes in the cosmos at all. Every electron in your body, and every photon leaving every screen you have ever stared at is doing it, quietly, all the time. It never needed you. And what it is doing is far harder to believe than the tidy little story about observation, which is exactly why the tidy little story was invented to cover it up. So get comfortable, because we are going to take this slowly. We are going to build it the way you build anything you actually want to understand, from the ground up, with nothing skipped and nothing assumed. And I am going to make you a promise for the end of the night. By the time we are done, you will know exactly what happens when you look. You will know what actually appears on that screen when the detectors are on, and every electron's path is known. And you will understand why almost everyone who has ever explained this experiment, including me, got the single most important part of it exactly backwards. But to see why the truth is so surprising, you first have to feel how reasonable the lie is. And that means starting with something no one argues about at all, something we have understood for more than 200 years. It means starting with what a wave does when it meets two slits. Let's begin there. Part 2. What a wave does. Picture the calmest thing you can. Picture the surface of a still pond, flat and dark, and imagine dropping a single stone into the centre of it. You know exactly what happens next, because you have seen it 1,000 times. A ring spreads outward from where the stone fell, and then another behind it, and another, a set of expanding circles rippling out across the water. That is a wave. It is not a thing travelling across the pond, not really. The water itself mostly stays where it is, bobbing up and down in place. What travels is the pattern, the up and down disturbance, moving outward through the water. Hold on to that, because it is the first crack in the wall. A wave is not an object. It is something an object does. It is a spreading, and a spreading can do things a solid thing can never do. Now let's build the experiment out of that pond. Imagine a straight barrier laid across the water, a low wall with two narrow gaps cut into it close together. And now, instead of dropping a single stone, imagine a steady train of waves rolling toward that barrier, one crest after another, like the parallel lines of surf rolling toward a beach. When those waves reach the wall, almost all of the water is stopped. But at each of the two gaps, something lovely happens. The wave squeezes through the narrow opening and, on the far side, spreads out again into a fresh set of expanding rings, as if a new stone had been dropped right there in the gap. So now you have two sets of ripples on the far side of the barrier, one spreading out from each slit, and the two sets are marching outward into the same stretch of water at the same time. And that is where the real magic begins, because now they have to share the water. Now they have to overlap. Watch what happens where they meet. In some places, a crest coming from the first slit arrives at exactly the same moment as a crest coming from the second slit. When that happens, the two crests add together and make a bigger crest, a taller peak of water than either wave could have made alone. This is called constructive interference, and it is just the simple idea that two pushes in the same direction make a bigger push. But in other places, something opposite happens. A crest from the first slit arrives at exactly the same moment as a trough from the second slit, a peak meeting a dip, an up meeting a down, and there they cancel. The peak fills in the dip, the up erases the down, and the water goes flat and still, as if no wave were passing through at all. This is destructive interference, and it is the strangest and most important idea in this entire experiment, so let it land fully. Two waves can add up to nothing. You can take wave and add more wave and get stillness. That is something no collection of solid objects could ever do. Two piles of sand added together never make an empty table. Stay with that idea a moment longer, because it is the single most counterintuitive thing about waves, and everything strange we meet tonight grows out of it. In the ordinary world of solid things, more is always more. Add more sand to a pile and the pile grows. Add more marbles to a heap and the heap gets bigger. There is no way with solid stuff to add something to something and end up with nothing. But waves do not obey that rule, because a wave is not stuff, it is a disturbance, a pattern of up and down, and two disturbances can work against each other. Where one wave is pushing the water up at the exact moment another wave is pulling it down, the two cancel, and you get stillness, flat calm, in a place where two waves are both arriving at full strength. This is why noise-cancelling headphones can make sound quieter by adding more sound, a second sound wave shaped to be the mirror image of the first, so that the peaks of one land in the troughs of the other, and they erase each other into near silence. It feels like it should be impossible, adding sound to make quiet, but it is exactly what waves do, and it is exactly what makes the dark bands in the double-slit pattern. Those dark bands are not places where nothing arrived. They are places where wave arrived from both slits, at full strength, and cancelled itself into darkness. Remember that, because when the electrons start making dark bands, the fact that a dark band is not emptiness but cancellation is going to be the thing that breaks the particle picture in half. If you were to place a screen behind the barrier, a wall standing in the water to catch whatever arrives, and you marked how much the water moved along that wall, you would find a very particular pattern. Right in the centre, directly between the two slits, the waves from both gaps travel the same distance, so their crests always arrive together and add up. That is a place of strong, tall waves, a bright band of motion. But move a little to one side, to a spot where the wave from one slit has to travel just slightly farther than the wave from the other, and you reach a place where crest meets trough, and the water goes dead flat, a band of stillness. Move a little farther and the crests line up again, another band of strong motion, then stillness, then motion. What you get all along that screen is a regular striped pattern, alternating bands of strong waves and no waves, marching outward from the centre in both directions. This striped pattern, these alternating bands, are the unmistakable fingerprint of a wave. Nothing but a wave makes them, because nothing but a wave can cancel itself out. When you see those bands, you are looking at the signature of something that spread out, went through both openings at once, and interfered with itself on the way to the screen. Now here is the part of the history that sets the trap for everything to come. For a long time, people argued about what light was. Isaac Newton, whose word carried enormous weight, had held that light was a stream of tiny corpuscles, little particles shot out from bright things like an unimaginably fine spray. and for about a century that was the respectable view, because Newton had said it. But around the year 1800, an English polymath named Thomas Young, a man so wide-ranging that he also helped decode Egyptian hieroglyphics, decided to send light through two narrow slits and see what it did on a screen behind. And what he saw were bands, bright bands and dark bands, the exact striped fingerprint of interference, the same pattern the water made in our pond. Light was going through both slits and interfering with itself, adding up in some places and cancelling to darkness in others. And that meant light could not be a stream of little bullets, because bullets cannot cancel each other out into darkness. Light had to be a wave. That single experiment, those simple stripes, overturned Newton and settled the question for the next 100 years. Light was a wave, full stop, and the double-slit experiment became famous as the thing that proved it. Now, you should know that this part is completely uncontroversial. When you shine ordinary light through two slits today, in any classroom in the world, you get those bands, every time, exactly as Young saw them. People sometimes point out that this is just classical optics, ordinary wave behaviour that we have understood for 2 centuries, and they are right. There is nothing quantum, nothing mysterious, nothing strange about light making an interference pattern. It is simply what waves do. Remember that, because later, when people insist that the light experiment is old news and has nothing to teach us about the true quantum world, we are going to discover they are wrong in a way that is genuinely startling. But feel what this history has done to your mind, because this is the trap. You now carry 2 beliefs, and they feel like solid common sense. The first belief is that stripes mean waves. If you see those alternating bands on a screen, something wave-like made them, something that spread out and went through both slits and interfered with itself. The second belief, sitting right beside it, is that the world is divided into 2 kinds of things. There are waves, like light and water and sound, and there are particles, like bullets and marbles and grains of sand, and these are 2 separate categories that behave in 2 separate ways. Both of these beliefs feel obviously true, and the double-slit experiment is about to take that second belief, the neat division of the world into waves over here and particles over there, and break it cleanly in half. To see how, we have to ask the opposite question. We have seen what a wave does through 2 slits. Now, what would a particle do? What should happen if we fire not ripples, but a stream of tiny, solid, individual things? Let's find out. Part 3. The 2 clumps. Let's put the waves away for a moment and imagine the most ordinary thing in the world. Imagine you have a machine that fires tiny pellets, little balls, one after another, in slightly random directions, spraying them toward that same barrier with the 2 slits in it. Think of it like a spray of paint, or a burst from a machine gun aimed at a wall with 2 gaps, or, if you like, a child throwing handfuls of sand at a fence with 2 openings. These are particles. Each one is a single, solid, indivisible little object. Each one is somewhere specific at every moment, and each one, when it reaches the barrier, either hits the wall and stops, or happens to be lined up with one of the 2 slits and passes straight through it. Ask yourself what pattern these pellets make on the screen behind the barrier. It is not a hard question, because your intuition already knows the answer with total confidence. A pellet that goes through the left slit continues on in a roughly straight line and lands somewhere behind the left slit. A pellet that goes through the right slit continues on and lands somewhere behind the right slit. Pellet after pellet, they stack up, and what you build on the screen is 2 piles, 2 clumps, one heap of pellets behind the left opening, one heap behind the right opening, each one roughly the shape and width of the slit it came through. Because our slits are narrow and set close together, the 2 piles might have a little bit of spread to them, might overlap slightly in the middle where their edges meet, blurring into one broad lumpy heap. But the essential picture could not be simpler. Particles make clumps. They make piles behind the openings they went through. They do not make stripes, and they cannot make stripes, for one absolutely fundamental reason. A single pellet is one object. It goes through one slit. It cannot go through both slits at once, because it is a solid indivisible thing, and a solid indivisible thing is in one place at a time. So there is no way for a pellet to interfere with itself the way a wave does, because there is nothing for it to interfere with. It did not split. It did not spread. It took one path through one gap and landed in one spot. You could fire 1 billion of these pellets, and you would never ever get a band of empty screens sitting between 2 bands of impacts, because that would require pellets that arrived and then somehow cancelled each other into nothing, and pellets do not cancel. Two pellets landing near each other just make a slightly bigger pile. There is no such thing as anti-pellet that fills in a hole. The striped pattern is forbidden to particles as surely as it is guaranteed to waves, and I want to head off the obvious objection right now because you might be thinking that with narrow slits set close together, the two piles would spread out and overlap so much that they would blur into something complicated, maybe even something that looks a little like bands. But it does not work, and the reason is worth being precise about. Even if the two piles spread and overlap completely, merging into one broad smeared heap in the middle, that heap is still smooth. It is brightest where the two piles overlap most and fades gradually toward the edges, one continuous mound of pellets with no gaps in it. What it can never have is a dark band in the middle of a bright region, a stripe where almost no pellets landed sitting right between two stripes where many did. Because for that to happen, you would need a place on the screen that pellets from the left slit can reach, and pellets from the right slit can reach, and yet where almost no pellets land, as if the two streams arriving together somehow produced fewer impacts than either one alone. With solid pellets, that is simply impossible. Two streams of pellets arriving at the same spot always make more pellets there, never fewer. The dark bands, the places where two contributions cancel to nothing, are the one thing solid objects can never produce, and waves always do. So the test really is clean. It is not clumps versus something vaguely spread out. It is smooth mound with no gaps versus a pattern with genuine dark cancellation bands cut into it. One is the unmistakable signature of particles. The other is the unmistakable signature of waves. There is no way to fake one with the other. So now you have the two possible outcomes laid out clean and clear, side by side, and they could not be more different. If you send waves through the two slits, you get stripes, the alternating bands of interference because a wave spreads out, goes through both slits, and interferes with itself. If you send particles through the two slits, you get two clumps, two piles behind the two openings, because a particle is one solid thing that goes through one slit and lands in one place. Stripes mean waves, clumps mean particles. This is the whole test. This is the entire logic of the experiment. Whatever you fire through those slits, you look at the screen, and the screen tells you what kind of thing you sent. Bands for waves, piles for particles. It is one of the cleanest yes or no questions in all of science. Now I want you to hold that image of the two clumps very, very carefully, because it is the single most important picture in everything we're going to do tonight, and it is important precisely because it is wrong. Not wrong as a description of pellets. Pellets really do make two clumps, and if you actually fired sand at a fence, you would get exactly what your intuition says. It is wrong in a way that is far more subtle and far more interesting than that. It is wrong because the popular story about the double slit experiment promises you that these two clumps are exactly what you recover the moment you start watching the electrons. The story says, leave the electrons unwatched and they act like waves and make stripes, but watch them, catch them in the act, force them to reveal which slit they went through, and they will surrender and behave like honest little pellets, and the stripes will collapse into these two tidy piles. The two clumps are supposed to be the proof, the visible evidence that observation reached in and turned waves into particles. Picture those two clumps in your mind, then, as a prediction, a confident prediction, the prediction that almost everyone who has ever explained this experiment quietly makes, the picture they draw on the board with such certainty that no one thinks to question it. Behind the left slit a pile, behind the right slit a pile, clean, solid, particle-like, exactly what bullets would do. That is the result the story promises. That is what is supposed to appear on the screen the instant you watch, and I am telling you now, before we even get there, so that you can feel the ground beneath you while it is still solid. Those two clumps never come. When physicists actually do this experiment, when they actually watch which slit the electron goes through, and then look at what lands on the screen, they do not find two piles, they find something else, something that is still, unmistakably, the fingerprint of a wave. The two clumps are the ghost of this entire story, the result everyone is sure of and no one has ever seen. But I am getting ahead of the night because we have not even sent the electrons through yet. We have only reasoned about what should happen. We have said that waves make stripes and particles make clumps, and that this gives us a perfect test. So let's actually run it. Let's take the electron, this thing that every physics book in the world lists firmly in the particle column, this tiny piece of solid matter with a definite mass and a definite electric charge, this thing that we are absolutely certain is a little bullet. Let's fire it at the two slits, one electron at a time, and watch what builds up on the screen. It should make two clumps. Everything we know about particles says it must make two clumps. Let's see whether the universe agrees. Let's see what the electron actually does. Part 4. The electron that went through both. The electron is about as solid a particle as anything we know. It has a definite mass, a specific tiny amount, the same for every electron in the universe. It has a definite electric charge, the smallest free charge that exists, and again exactly the same for every one of them. Electrons are the things that flow through wires to make electric current. They are the things whose rearrangement makes every chemical reaction, every fire, every breath in your lungs, every signal firing along your nerves right now as you listen. They are, as far as anyone has ever been able to tell, tiny points of matter with no size we have ever been able to measure, genuine little bullets if anything in the universe deserves that name. If you had to bet on any object behaving like a particle in the two-slit experiment, you would bet everything you own on the electron. So let's watch it. We fire them one at a time. This matters, so hold on to it. We're not spraying a crowd of electrons all at once where they might jostle and push on each other and make a mess. We're releasing a single electron, letting it cross the apparatus alone, letting it land, and only then releasing the next one. One electron, then another, each one completely alone in the machine, with no other electron anywhere near it to interfere with. And on the screen behind the two slits, each electron announces its arrival as a single, sharp, tiny dot. A point of light where it struck. Not a smear, not a ripple, not a spread-out band, but a single dot, precise and localized, exactly where that one electron hit. Tick, a dot. Tick, another dot, somewhere else. Tick, another. At first, this looks like a total victory for the particle picture, and you should let it feel that way, because the physicists felt it too. The electrons are arriving as dots, individual, countable, particle-like dots, each one landing at a single spot just as a tiny pellet would. There is no spreading, no wave washing across the screen. Each electron is clearly a little something that goes to a little somewhere. 10 dots, 20. They seem scattered, a little random, sprinkled across the screen without any obvious order. Your intuition relaxes. Of course, electrons are particles. Look at them, landing one by one like grains of sand. Whatever strange thing happens with light and water, matter is matter, and a bullet is a bullet. But keep watching, because the dots keep coming, and something begins to happen that should not be able to happen. Let the pattern build. 100 dots now scattered across the screen, a few hundred. And slowly, out of what looked like pure randomness, a shape starts to haunt the screen. The dots are not falling evenly. There seem to be certain vertical lanes where dots love to land, where they pile up thick and bright, and between those lanes there are gaps, bands where almost no dot ever falls, where the screen stays dark. 1,000 dots. 10,000. And now there is no denying it, no explaining it away. The dots have arranged themselves into stripes, bright bands where thousands of electrons struck, separated by dark bands where almost none did. The alternating fingerprint of interference, the exact same striped pattern that the waves made in our pond, that Thomas Young saw with his light 200 years ago. The signature of a wave. Sit with how impossible this is. Each electron arrived as a single dot, a particle, at a single point. But the population of dots, the pattern they built up together, is the pattern of a wave that went through both slits and interfered with itself. And remember, we fired them one at a time. Each electron crossed the machine completely alone. There was no second electron for it to interfere with. So whatever went through both slits at once and decided where this single, lonely electron was allowed to land, whatever cancelled it out from the dark bands and guided it into the bright ones was the electron interfering with itself. A single, indivisible speck of matter, somehow spread across both slits at the same time, rippling against its own possibilities, and then collapsing down to one bright dot on the screen. The bullet went through both holes. The bullet was, in some sense we do not have words for, a wave. Let me put you inside that lab, because this is not a thought experiment. This was really done, and I want you to see it. Imagine you're standing in a darkened room in front of a screen, and the apparatus is releasing a single electron at a time. The first electron arrives. A lone speck of light flares somewhere on the screen, apparently at random, and fades. Then another, in a completely different place. Then another, off to the side. For a while it looks like nothing at all, like static, like faint dust settling with no order, and every instinct in you says these are just little bullets landing where little bullets land. 10 specks, 100. Still no pattern the eye can trust, just scattered points in the dark, but you keep watching, because the machine keeps releasing them, patient, one at a time. And after 1,000, a ghost begins to rise out of the noise, faint vertical lanes, places where the specks seem to prefer to fall, and thin gaps where they almost never do. After 10,000, it is undeniable. Clean bright stripes and dark bands, an interference pattern, assembling itself in front of you one particle at a time, out of what looked like pure chance. And the vertigo of it, the thing that made the physicists who first saw this go quiet, is that every single one of those electrons crossed the machine alone. Each one, by itself, had to somehow go through both slits, ripple against itself, and choose its dot. You're watching single, solid pieces of matter, released one at a time, negotiate with their own spread-out possibilities before collapsing into single points of light on the glass. This is not a modern trick or a fringe result. The wave nature of matter was predicted in the 1920s by a French physicist named Louis de Broglie, who made the astonishing suggestion that if light, long thought a wave, could act like particles, then perhaps particles, like electrons, could act like waves, and he wrote down the simple relationship between a particle's motion and the wavelength it would have. Within a few years, two physicists named Clinton Davison and Lester Germer, working in America, accidentally confirmed it, scattering electrons off a crystal and seeing them diffract exactly as waves would. The actual two-slit experiment with electrons was performed in 1961 by a physicist named Klaus Jonsson, and the single electron version, the one where you can watch the dots arrive one at a time and build the pattern, was captured in a beautiful experiment in 1976 by a team in Bologna, Italy, and then filmed even more clearly in 1989 by Akira Tonomura and his colleagues in Japan, whose footage of single electrons stacking up into stripes has been watched by physics students ever since. This is as solid as science gets. There is a wave associated with every electron. It passes through both slits. It interferes with itself, and the only difference between it and a wave on a pond is that the electron, when it finally arrives as a single dot. And I want you to feel how much resistance this idea met, because it tells you these were not fools who gave in easily. When Louis de Broglie first suggested, in his doctoral thesis, that matter might have a wavelength, that solid particles might have waves, the idea was so strange that his examiners genuinely did not know what to make of it. It was only when Albert Einstein, who was sent the thesis, said that the young man was onto something real, that it was taken seriously at all. And then the experiments came, and the experiments do not care what feels reasonable. Davison and Germer were not even trying to prove de Broglie right. They were doing something else entirely, bouncing electrons off a nickel crystal, when their equipment had an accident that changed the surface of the metal, and suddenly the electrons started coming off in a pattern that made no sense for particles and perfect sense for waves. They had accidentally built a device that showed electron waves diffracting, and when they worked out the wavelength, it matched de Broglie's prediction exactly. That is how the wave nature of matter entered physics, not through philosophy but through hard, stubborn, reproducible fact, confirmed by people who mostly did not want it to be true and could not make it go away. The universe simply insisted. It kept showing them the stripes, and these are not exotic particles in some far-off laboratory that have nothing to do with you. These are electrons. The same electrons that make up the atoms in your hand, the same electrons flowing through the device that is carrying my voice to you, the same electrons streaming down every nerve in your body to build this very moment of listening in your mind. Whatever an electron truly is, you are made of it, top to bottom, and it turns out that nobody can honestly say it is simply a particle. It goes through both slits. So now we have a genuine mystery on our hands, and it is a mystery that begs for an obvious response. If a single electron is really going through both slits at once, then let's catch it. Let's not just infer it from the pattern. Let's put a detector right at the slits and watch the electron do the impossible thing with our own eyes. Let's catch it in the act. And that, it turns out, is where the trap is waiting. Part 5. Let's catch it in the act. The idea is irresistible, and every single person who learns about this experiment has it, If the electron is somehow going through both slits at the same time, then let's prove it directly. Let's stop inferring it from the striped pattern and instead station a little watcher at each slit. A detector, a device that fires off a signal whenever an electron passes through its particular gap. Put one at the left slit and one at the right slit. Then fire your electrons and watch the detectors. If the electron really is going through both slits at once, you should see both detectors fire at the same time for a single electron. You would catch it red-handed, spread across both openings, doing the thing that no particle should be able to do. You would have your proof, direct and undeniable. So they did exactly this. They put detectors at the slits and fired the electrons and watched. And here is the first surprise, the one that everyone forgets to mention. You never catch the electron going through both slits. Never. Not once. Every single time an electron passes the detectors, you get one signal from one detector. This detector fires, or that one does, but never both together for a single electron. The electron is always found at one slit. You went looking for the electron in two places at once, and the universe refused to show it to you that way. Every time you actually check, the electron is somewhere specific, at one slit, like a proper particle. It is as if the electron will happily go through both slits when nobody is checking, but the instant you demand to know which slit, it gives you a straight answer. This one. This is genuinely how measurement works in the quantum world, and it is worth slowing down for because it is the real physics underneath the myth, and it is strange enough on its own without any exaggeration. Before you check, the electron is in what physicists call a superposition. It is not secretly going through one slit and fooling you. It is genuinely in a spread-out state that includes both slits at once, both possibilities coexisting, which is exactly what lets it interfere with itself and build the striped pattern. But when you make a measurement, when you force the question of which slit, you never get both as an answer. You get one definite result. The superposition, that spread out both at once state, collapses down to a single definite outcome. The electron is here, at this slit, and this collapse is real. The act of measuring genuinely changed the electron. A moment ago it was spread across both slits. Now, because you looked, it is passing through only one. I want to be careful here, because there is a tempting way to misunderstand this that would let you keep your old intuitions, and it is wrong. You might think, well, the electron was really going through one slit all along, secretly, and it was just hiding it from us, and when we measured, we simply found out which one it had chosen. That would be comfortable. That would let the electron stay a particle the whole time, sneaking through one slit while pretending to be a wave. But that is not what is happening, and we know it is not, because if the electron had really been going through one definite slit all along, there would be no interference pattern when we do not watch. A thing that goes through one slit makes a single slit pattern, not the two slit stripes. The only way to get the fine two-slit interference is for the electron to genuinely go through both slits, as a spread-out wave, with no fact of the matter about which one, right up until you measure. The superposition is not the electron hiding a secret answer. It is the electron genuinely not having a single answer yet, being genuinely spread across both possibilities at once. And measurement does not reveal a pre-existing answer. It creates one, forces one into existence, out of a state that truly had none. That is the real strangeness, and it is why measurement matters so much. It is not a discovery of what was already true, it is the moment a spread-out maybe becomes a single definite is. Everything I have just told you is completely correct and completely standard. I want to be emphatic about that, because it matters enormously for what comes next. Yes, the measurement is real. Yes, before you measure, the electron is genuinely in a superposition across both slits. Yes, when you measure which slit, you always get one definite answer, and the act of measuring collapses that superposition and really does change the electron so that it now goes through only one slit. None of that is the lie. The popular story has walked with us, faithfully and accurately, right up to this exact point. The electron was spread across both slits. You measured it. It collapsed to one slit. It is now, in a real sense, localized, definite, passing through a single opening like a particle. So far, so true, and it is right here, at this precise moment, with the electron freshly measured and freshly localized to one slit, that the story takes one small step that feels completely obvious and is completely wrong. The story says, well, Now that we have measured the electron and collapsed it to one slit, now that it has been forced to be definite and particle-like, it will behave like a particle for the rest of its journey. It will travel in a straight line from its one slit to the screen and land in a pile behind that slit. And since we are measuring every electron, forcing each one to a single slit, we will build up two piles, two clumps, one behind each slit. The stripes will be gone, replaced by the honest particle pattern. Observation will have turned the wave into a particle, and the two clumps will be the proof. It sounds airtight. It sounds like nothing more than following the logic through. The electron was measured. It became definite. Definite things are particles. Particles make clumps. Every step feels forced by the one before it, and that is exactly why this is the most convincing lie in physics, because it does not feel like a lie at all. It feels like the obvious conclusion. It is the conclusion I drew, the conclusion in the textbooks, the conclusion in the documentaries. Measured electron, therefore particle, therefore two clumps. Who could argue? The universe could. Let me put you at the switch, in the final moment before the truth arrives. Imagine you are standing at the apparatus with your hand resting on the control that turns on the two-slit detectors. Right now, the detectors are off, and the screen in front of you is glowing with the striped interference pattern, those clean, bright bands built up from thousands of electrons that were each, somehow, going through both slits at once. You're about to change that. You're about to switch on the detectors and force every electron to declare its slit, and you know, with total confidence, exactly what is going to happen, because you have been told this story your whole life, and it makes perfect sense. The stripes are going to vanish. In their place, two clean piles are going to build up, two clumps, one behind each slit, as the electrons stop their wave-like nonsense and snap to attention, like soldiers caught out of formation, becoming honest little bullets the moment they are watched. You believe this completely. Every physicist you have ever heard believed it. Flip the switch, watch the screen, and watch what actually forms not be two clumps at all. Hold there, right on the edge of your certainty, because the gap between what you are sure you're about to see and what the universe is actually going to put on that screen is where the floor of this entire story gives way. So let's flip it. Let's turn on the detectors and watch which slit every electron goes through, and then let's look, honestly and carefully, at what actually appears on the screen. Not what the story promises, not what your intuition demands, what the experiment actually shows. Let's finally answer the question this whole night has been walking toward. What actually happens when you look? Part 6. What actually happens when you look. You turn on the detectors. Now you know which slit every single electron passes through. Each electron trips one detector and one detector only, the left or the right, and you have a complete record of every electron's path. There is no ambiguity anymore, no superposition you are aware of, no mystery about where each one went. You watched them all, and now you look at the screen to see the pattern they built. According to the story, according to everything you were promised, you should be looking at two clumps, two neat piles behind the two slits, the honest particle pattern, the visible proof that watching turned the waves into bullets. That is not what is on the screen. There are no two clumps. There is no pair of tidy piles behind the two slits. Instead, what has built up on the screen is a broad, bright band in the center, wide and strong, and then, fading out on either side of it, a series of dimmer bands, weaker stripes rippling away from the middle and getting fainter as they go. It is not two piles. It is a pattern, a spread-out, banded, rippling pattern, brightest in the middle and fading in rhythmic steps toward the edges. And if you've been paying attention all night, a cold feeling should be starting to creep up your spine, because you have seen this kind of thing before. This is not the pattern of particles. This is, once again, the fingerprint of a wave. Let me be precise about what changed and what did not, because this is the exact hinge of the entire experiment and the exact place where everyone goes wrong. Two things are true at once. First, the fine stripes did change. The tightly packed, closely spaced bands you saw when the detectors were off, the ones that came specifically from the electron going through both slits and interfering with itself, those are gone. That much of the story is actually correct. Watching does destroy the two-slit interference pattern, but, and this is everything, what replaced it is not two clumps. What replaced it is a different interference pattern, a broader one, the pattern you get from a wave going through a single slit. because it turns out that even one slit, all by itself, makes an interference pattern if what goes through it is a wave. Here is why, and it is not complicated. When a wave passes through a single narrow opening, it does not just march straight through and make a clean shadow of the slit. It spreads, it fans out from the edges of the opening, and the parts of the wave coming from slightly different points across the width of that one slit interfere with each other. The result is a pattern, a strong bright band in the centre, where all the parts of the wave line up, and then dimmer bands on either side where they partly cancel and partly reinforce in a fading rhythm. This is called single-slit diffraction, and it is pure wave behaviour. It is interference. It happens because the thing going through the slit is spread out and can cancel and reinforce against itself. A stream of tiny bullets going through a single slit would never make this. Bullets through one slit make one pile, a simple shadow of the opening. They make a clump. They do not make a bright central band with rhythmic fading bands beside it, because a bullet has nothing to interfere with. So this pattern, the single slit pattern, is not the particle result. It is still, unmistakably, the wave result. Do you see what this means? Do you feel the flaw going? You measured the electron. You collapsed its superposition. You forced it to go through one definite slit. You did everything the story said would turn it into a particle. And it still made an interference pattern. It still behaved like a wave. It just behaved like a wave going through one slit instead of a wave going through two. The measurement did not turn the electron from a wave into a particle. It narrowed the wave. It took a wave that was spread across both slits and squeezed it down to a wave going through one slit. And that one slit wave still spread, still diffracted, still interfered with itself, still landed in a rippling banded pattern that no stream of bullets could ever produce. The electron was a wave before you looked, and it was a wave after you looked. The looking never made it a particle at all. This is the lie, laid bare. The whole intoxicating story, the one that says observation collapses waves into particles, the one that puts your gaze at the centre of reality with the power to turn possibility into solid matter, rests entirely on those two clumps appearing when you watch. And they do not appear. They never appeared. When you actually do the experiment and actually look at the screen, the watched electrons make a wave pattern, the single slit diffraction pattern, every time. The electron does not stop being a wave when you observe it. Nothing you can do makes it into a little bullet flying in a straight line. There is even a precise, rigorous way physicists have written this down, a relationship discovered in stages in the late 1980s and 90s that says the more information you have about which slit the particle went through, the fainter the two slit fringes become in a smooth, continuous trade-off. Not a sudden snap from wave to bullet, a dial. As you gain path information, the fine fringes gently fade, and underneath them, always, is the single slit wave pattern. There is never a moment where the wave becomes a particle. There is only a wave that is sometimes spread across two slits, and sometimes narrowed to one, and always, underneath everything, a wave. I want you to sit here for a moment, in the quiet after the floor has gone, because there is something worth feeling before we rebuild. You have carried, probably for years, a comforting idea that when you look hard enough at reality, it settles down and behaves, that being watched makes things definite, ordinary, solid, particle-like. It is a very human idea, that attention brings order, that observation makes the world snap into sensible shape, and the single slit pattern on that screen is the universe gently, patiently declining to do that. The electron was watched, its path was fully known, and it still refused to be a bullet. There is a small grief in losing the tidy story, the one that made the universe feel like it had a simple, on-off switch labelled observation. But underneath the grief, if you let yourself feel for it, something much larger is arriving. Because if measuring the electron did not make it a particle, then maybe the electron was never the kind of thing that is sometimes a wave and sometimes a particle in the first place. Maybe those were always our words, our two little boxes, and never its nature at all. And that idea, once it takes hold, does not just correct the double slit experiment. It quietly begins to dissolve the whole division of the world into waves and particles that you have carried since you were a child. Let yourself feel the full size of what just happened, because it is easy to rush past, and I do not want you to. You did everything right. You did everything the story told you to do to make a particle. You placed the detectors. You measured the path. You collapsed the superposition. You forced the electron to declare a single slit, and it declared one, honestly, every time. By every instruction in the popular account, you had it cornered. It should have been a little bullet now, definite and watched and pinned down, flying to its clump, and it looked at you, so to speak, and made an interference pattern anyway. It stayed a wave in the one way that was supposed to be impossible for a watched thing. There is something almost patient about the universe's refusal here, something that is not dramatic at all, and that is what makes it land so hard. It did not resist you loudly. It just quietly kept being what it always was, a wave, while you did everything you could think of to make it into something else. And the small human grief in that moment is real. You wanted the world to have a switch. You wanted attention to be the thing that makes reality settle and behave, because that would mean that when you look hard at your life, at your problems, at the things you cannot control, your looking might bring them to order. The single slit pattern is the gentle, ancient answer to that wish. The world does not become solid because you watch it. It was never going to. And underneath that small grief, if you stay in it long enough, there is the beginning of a much larger and stranger comfort, which we will not be able to name fully until the very end of the night. But feelings are not understanding, and I promised you understanding. It is not enough to know that the story is wrong. You deserve to know what is actually going on, the real machinery underneath, so that no one can ever sell you the lie again. Because there is a correct account of all of this, and it is not mystical, and it is not vague, and once you have it, this entire experiment stops being a paradox and becomes something you can hold in your hand. It all comes down to one idea, the single most important and most misunderstood idea in quantum mechanics. It comes down to the wave that was never a metaphor. Let's build it. Part 7. The wave that never stopped being a wave. Every quantum object, an electron, a particle of light, anything at all at this scale, has associated with it a wave. Not a wave in water, not a wave in any material, but a wave of its own, which physicists call the wave function. It is the most successful, most precisely tested idea in the entire history of science, and it is the thing the whole double-slit experiment is really about. So let me tell you what it is and what it does, plainly, with nothing left mysterious, because once you have it, everything we have seen tonight clicks into place like a key turning in a lock. The wave function is a wave that describes where the object is likely to be found. That is the crucial thing about it. It is a wave of possibility, of likelihood, spread out through space, tall in some places and low or absent in others. Where the wave is strong, the object is likely to be found. Where the wave is weak or zero, the object is unlikely or forbidden to be found. And this wave behaves exactly like a wave in every way that matters. It spreads. It goes through openings. It can pass through two slits at once. And when it does, the part that came through one slit overlaps with the part that came through the other, and they interfere, adding up in some places and cancelling in others, just like the ripples on our pond. When both slits are open and nothing is watching, the electron's wave function passes through both slits, interferes with itself, and forms a pattern of likely here, unlikely there, likely here, unlikely there, across the space in front of the screen. That pattern of likelihood is exactly the striped interference pattern. The bright bands are where the wave function is strong, where electrons are likely to land. The dark bands are where the wave function cancelled itself to zero, where electrons almost never land. The electron is guided in where it is allowed to go by this wave. Now watch what the measurement really does, in terms of the wave. When you turn on the detectors and find the electron at one slit, you do not turn the wave into a bullet. You collapse the wave function from a two-slit wave into a one-slit wave. Before the measurement, the wave was spread across both openings. After the measurement, because you found the electron at, say, the left slit, the wave is now passing through only the left slit. But it is still a wave, and a wave passing through a single opening still spreads, still fans out from the edges of that one slit, still interferes with itself, and still makes an interference pattern, the single slit diffraction pattern we saw on the screen. At no point in this entire story does the wave ever become a classical particle travelling in a straight line. From the moment the electron leaves its source to the moment it strikes the screen, it is described by a wave, spreading and interfering. The measurement at the slits does not end the wave, it just reshapes it, narrows it, from a two-slit wave to a one-slit wave. That is the whole difference. That is why the pattern changed from the fine two-slit stripes to the broad single-slit bands. Not wave into particle, just wave into a narrower wave. But wait, you might say, if it is a wave the entire way, spread out and rippling, then why does it arrive as a single sharp dot? Why not a smear, a spread-out wash of electron across the whole screen, the way a water wave wets the entire shoreline at once? This is the last piece, and it is the strangest and deepest rule in all of quantum mechanics, so let it land carefully. The rule is this: whenever you measure the position of a quantum object, whenever you force it to answer the question, where are you? It is compelled to appear at one single definite place, not spread out, one point, and which point it appears at is chosen at random with the odds set by the wave. Where the wave is strong, the object is very likely to appear. Where the wave is weak, it is unlikely. Where the wave is zero, it cannot appear at all. So the screen is a position measurement. When the electron's spread-out wave reaches the screen asks it, where are you? And the wave, which was spread across the whole screen as a pattern of likelihood, is forced to gamble everything on a single point. It appears as one dot, and the dot is more likely to fall where the wave was strong, in the bright bands, and almost never falls where the wave cancelled to zero, in the dark bands. Fire a single electron and you get a single dot, apparently at random but weighted by the wave. Fire thousands, one at a time, and the dots pile up according to the wave's pattern of likelihood, building the stripes. The dot is not the electron finally being a particle. The dot is the wave being measured, and measurement of position always yields a single point. The wave decides the odds. The point is just where the dice landed that time. This is not loose talk or metaphor. The mathematics of this was written down in the 1920s, the equation for how the wave function behaves by Erwin Schrödinger, and the rule that the strength of the wave gives the probability of finding the object by Max Born, and it has been tested for 100 years to a precision that beggars belief, and it has never once been found wrong. This is the most reliable knowledge our species has ever produced. And notice what it does to the word collapse, which sounds so dramatic, so mystical in the popular tellings. Collapse is just this: a spread-out wave of possibility, when asked where it is, being forced to answer with one point. That is all. There is no magic in it, no consciousness required, no reaching in from somewhere outside the world. There is a wave of likelihood, and there is the moment it is measured, and at that moment it delivers a single location chosen by its own odds. I do not want you to take my word for how well tested this is, so let me give you a sense of it. The framework built on this wave, the framework that says the wave gives you the odds, and measurement gives you the single result, has been checked against experiment for 100 years, and in some cases the agreement between what the theory predicts and what the experiment measures runs to 10, 11, 12 decimal places. To put that in some kind of human perspective, that is like predicting the distance across an entire continent and being right to within the width of a single human hair. There is no other theory in the history of science that has been tested this hard and passed this cleanly. Every piece of technology you have ever touched that involves a computer chip, a laser, an LED, a medical scanner, works because this framework describes reality correctly, and if it were even slightly wrong, those devices would fail. So when I tell you that the electron is a wave of likelihood that delivers a single whole unit when its position is measured, I am not telling you a story or an interpretation or a nice way of thinking about it. I am telling you the single best-tested description of reality our species has ever produced, the one that every working piece of quantum technology on Earth silently relies on every second to keep working. The strangeness is not a gap in our knowledge. The strangeness is the most confirmed thing we know. Let me put you inside the wave itself so you can feel it. Imagine you could ride along with a single electron, and imagine the detector at the slit has already fired and announced its answer. This electron is going through the left slit. This is the exact moment the story says the electron has become a particle. So ride with it now, through that one slit, and see whether it feels like a bullet. It does not. What passes through the slit with you is not a hard little ball, but a spread-out swell, a hump of wave as wide as the opening itself. And the instant it clears the slit, it begins to fan outward, because a wave squeezed through a narrow gap always spreads. It cannot help it. The two edges of the slit peel the wave into overlapping parts, and those parts begin to interfere with each other, reinforcing here, cancelling there, painting an invisible landscape of likely and unlikely across the darkness ahead of you. You're not a stone flying in a straight line toward a spot on the screen. You're this whole spreading, self-interfering swell, arriving at the screen not as a point but as a pattern of possibility, brightest in the center, fading in bands toward the edges, and only at the very last instant, when the screen measures where you are, does the whole spread-out swell gamble itself on a single point, and a lone dot flares into being, far more likely in the broad, bright center, almost never in the dark troughs the wave has cancelled to nothing. Feel it clearly. The particle was only ever the final flash of measurement. Everything before it, even under the detector's eye, even after you knew which slit, was wave all the way down. So here is where we stand, and it is worth catching our breath and stacking up what we have, because we have quietly overturned the entire popular story. The electron is a wave from the moment it is born to the moment before it lands. That wave goes through both slits when unwatched and makes two slit stripes. When you watch, it collapses to going through one slit, but stays a wave and makes single slit stripes. It never at any point becomes a little bullet flying in a straight line, and the dot it makes on the screen is not the electron being a particle. It is just what happens when you measure the position of a wave. It is forced to show up at one point. The looking never made a particle. The looking only ever narrowed a wave and then, at the screen, asked it where it was. But this raises a fair and sharp question, maybe the sharpest question in the whole night. If the electron is a wave through and through, if it is never really a particle at all, then why do we call it a particle? Why does the word exist? What is it about the electron that is particle-like, if the whole journey is wave? There is an answer, and it is the one honest grain of truth buried inside the lie, and it points at something even stranger than everything we have seen so far. Part 8. The one thing that makes them particles. If electrons are waves from the source to the screen, in what sense are they ever particles at all? There is exactly one sense, and it is worth finding precisely, because it is the real grain of truth that the myth took and inflated into something false. Here it is. Electrons are particle-like in one way and one way only. They always arrive whole. When an electron lands on the screen, one entire electron lands. The full electron mass, the full electron charge, delivered to a single spot. You never get half an electron landing here and half landing there. You never get a smear of a third of an electron spread along the bright band. Even though the wave was spread out across the entire screen, even though it went through both slits and rippled across all that space, when it is finally measured, it delivers one complete indivisible electron to one place. The wave is spread out. The arrival is whole. Think about how different this is from a water wave. When an ocean wave reaches a long beach, it does not pick one grain of sand and deliver all its energy there. It breaks along the entire shoreline at once, sharing its energy across the whole length of the beach, wetting everything a little. A water wave is divisible. It can give a bit of itself here and a bit there, spreading its influence continuously along everything it touches. But the electron's wave does not do that. No matter how far it has spread, no matter how wide across the screen its possibility reaches, when it is measured it hands over one entire electron whole and complete and never divided to a single point. And the next electron does the same, at its own single point. This is the discreteness, the countability, the arrival in whole indivisible units, and this, and only this, is what makes us want to call the electron a particle. And it turns out this whole arrival, this countability, is not some minor detail. It is one of the most important facts in all of physics, because it is why the world is made of distinct things at all. It is why there is such a thing as one electron and two electrons and a countable number of them, rather than just a continuous electric jelly smeared through space. The universe, at its finest grain, comes in whole units, in packets, in countable lumps. When you measure it, you always get a whole number of things, never a fraction. This is the actual meaning buried inside the word quantum, which simply means a discrete amount, a countable packet. The quantum world is the world where things come in whole units, and so the electron genuinely does have a particle-like quality. It is real. It is not the lie. And this whole arrival is stranger than it first sounds, because think about what the wave has to do to make it happen. The wave was spread out across the entire screen, reaching everywhere the interference pattern reached. A swell of possibility that might have delivered its electron anywhere in the bright bands. It had, in a sense, presence across all of that space at once. And then, in the instant of measurement, All of that spread out presence, everywhere it reached, has to gather itself and hand over one complete electron at exactly one point, and nothing anywhere else. The possibility that was strong over here and strong over there and strong across the whole pattern collapses, in that instant, to a single actual arrival, whole and entire at one spot. It is as if the wave, which was genuinely everywhere it could be, is asked, "Give me one whole electron at one place," and it does, and every other place where it might have delivered that electron gets nothing. The electron is never split. The wave is spread across the whole screen, but the electron it delivers is always one, always whole, always at a single point. That the spread out can become the singular, without ever splitting, without ever delivering a fraction, is the strange and unexplained heart of the whole thing, and it is why the countable, particle-like quality is real and worth respecting, even as we insist the journey was all wave. The wave is how it travels, the whole unit is how it lands. Both are true, neither is the lie. The lie was only ever the claim that watching converts one into the other in mid-flight, but now look very carefully at what that particle-like quality actually attaches to, because this is the whole game. The countability, the whole arrival, the indivisible unit, all of it belongs to the moment of measurement, the moment of arrival, the moment of being detected. It does not belong to the journey. During the journey from source to screen, the electron is a spread-out wave, going through both slits, interfering with itself, behaving in every way like a wave and in no way like a bullet. It is only at the instant of measurement, the instant it is caught, that it delivers itself as one whole countable unit. So the particle is not a description of the electron sailing through the slits. The particle is a description of what happens when the wave is measured. The particle is an event, not an object. It is the name of the moment the wave is asked where it is, and answers with one whole lump at one point. Sit with that inversion, because it turns the entire question inside out. We have spent this whole night, and physics spent decades, asking, is the electron a wave or a particle? And the answer is that this was the wrong question, because it assumed the electron had to be one kind of thing or the other, sitting in one of our two boxes. But the electron is a single thing that travels as a spread-out, self-interfering wave, and is delivered, when measured, as one indivisible countable lump. Wave in flight. Whole unit on arrival. Always both, never switching, because the two descriptions apply to two different moments, the travelling and the measuring. Say it that way, and the famous paradox simply dissolves. There is no contradiction between the wave and the particle, because they were never competing descriptions of the same moment. The wave is what it does on the way. The particle is what you get when you catch it. And notice, with a little quiet satisfaction, what this does to the lie. The lie said observation turns the wave into a particle, as if watching reached in and transformed the object's very nature partway through its flight. But the truth is that the particle was never a stage in the flight at all. It was always just the arrival, the measurement, the catching. The electron does not travel as a wave and then, when watched, travel as a particle. It travels as a wave, always, and it arrives as a whole unit, always. Watching the slits does not insert a particle phase into the journey. It just narrows the wave from two slits to one, while the wave keeps right on being a wave, and the whole unit arrival keeps right on happening at the screen exactly as it always did. The one genuinely particle-like thing, the whole arrival, was never in competition with the wave and never evidence against it. It was happening the whole time, wave and countable arrival together, watched or unwatched, and it always will. This is the sentence you get to keep, the one that will make you immune to the lie for the rest of your life. The next time someone leans in and tells you that observing the double-slit experiment turns the waves into particles, that watching collapses possibility into solid little bullets, you will know the truer and stranger thing. You will know that the wave never stops being a wave. You will know that the particle was only ever the shape of the moment it was caught, the whole unit delivered at the instant of measurement, and never a description of the thing in flight at all. You will know that there are no little bullets flying through the slits, watched or unwatched, only a wave of possibility and the countable lumps it delivers when it is asked where it is. But I have been talking this whole time about electrons, about matter, about the things we were surprised to find behaving like waves, and you might be thinking, fine, matter is strange, electrons are strange, but at least light is simple. Light is obviously a wave. We proved that 200 years ago with Thomas Young. Surely light at least does not have a hidden particle side that plays the same trick, and here is where the two halves of this story come together, because light was hiding the exact same secret all along. Part 9. Light was hiding the same secret. Here is the objection everyone raises, and it is a good one. Electrons, you might say, are just weird. They are matter, and it turns out matter is secretly wavy. Fine. But light is different. Light is obviously a wave. We settled that with Thomas Young and his stripes 2 centuries ago. So surely a single particle of light, a photon, is a proper little bullet of light. Surely if you could send light through the slits 1 photon at a time, you would finally see the honest particle behavior. 1 photon going through 1 slit, landing in 1 place, building 2 clumps. People ask for exactly this experiment constantly. Do it with single photons, they say. Turn the light down until only 1 photon at a time is crossing the apparatus, and then you will see the particle nature of light, clean and simple. So let's think about what actually happens when you turn light down. How do you make light dimmer? You put something in the way that blocks most of it. A filter, a piece of dark glass, something that only lets a fraction of the light through. And here is the quiet truth that undoes the whole objection. Putting a filter in front of a light source does not chop the light into bullets. It just makes the wave weaker. Think of the light as a wave, which we have known it is for 200 years. A filter makes that wave smaller, lower, dimmer, the way turning down a sound makes the sound wave quieter. But a quieter wave is still a wave. A dimmer light wave still spreads out, still passes through both slits, still interferes with itself, exactly as it did when it was bright. You can keep adding filters, making the wave weaker and weaker and weaker, and at no point does the wave suddenly become a little ball. It just becomes a fainter and fainter wave. There is no filter in the world that turns a wave into a bullet. It only ever turns a strong wave into a weak one, so you should still get the interference pattern, no matter how far down you turn the light, because you still have a wave going through both slits, and you do. Turn the light down as low as you like, and the striped 2-slit pattern is still there, just fainter. The wave nature of light does not go away when you dim it, because dimming is just weakening the wave, and a weak wave is still a wave. So far this is exactly what you would expect. But now something new happens, something that does not happen with a bright light, and it is the thing that fools absolutely everyone. When the light gets faint enough, it stops arriving as a smooth, continuous glow. It starts arriving as individual dots, single specks of light, appearing one at a time on the screen, each one at a single spot, exactly like the electrons did. Flick, a dot, flick, another. The smooth wave of light has apparently broken into particles, but it has not become a particle. Watch this carefully, because the explanation is the whole point. The reason you suddenly see individual dots when the light is faint is not that the wave turned into bullets. It is that the light was always arriving in dots, even when it was bright, and you just could not see them because there were so many. When the light is at full strength, there are so many of these dots landing every second, billions upon billions, that they blur together completely and look like a smooth continuous glow, the way the individual frames of a film blur into smooth motion, or the way a fast enough drum roll becomes a single tone. The dots were always there, you just could not resolve them, and when you turn the light down, all you're doing is slowing the arrivals, spacing them out, until finally they come slowly enough that you can see them arrive one at a time. Turning the light down did not create particles, it only slowed the wave's arrivals until your eye could finally count them. Each of those dots is a photon, a single whole unit of light, and, exactly like the electron, a photon is particle-like in one way and one way only. It always arrives whole. Light comes in whole units of energy, and for a given color of light, every one of those units is exactly the same size. This is one of the foundational discoveries of quantum physics, that the energy of light is not infinitely divisible, but comes in these fixed packets, these photons, whose size is set by the color of the light. So faint light through a double slit builds up the striped interference pattern, one dot at a time, each dot a single whole photon landing at a single spot, weighted by the wave, more likely in the bright bands and almost never in the dark ones, slowly stacking up into the exact same stripes the bright light made all at once. It is the electron experiment, precisely, in every detail. A wave that spreads and interferes and goes through both slits, arriving as whole countable units, guided by the wave into an interference pattern. This is not speculation or a modern refinement. It was first seen astonishingly early, in 1909, when a physicist named Geoffrey Ingram Taylor made the light in a double-slit experiment so unbelievably faint and exposed his photographic plate for months that only a tiny trickle of light was passing through at any moment, and the interference pattern still built up, dot by patient dot. It was pinned down rigorously in 1986 by a team led by Alain Aspect and his colleagues in France, who used genuine, verified single photons and showed that even one photon at a time interferes with itself. And in 2016, 3 physicists named Reuben Aspdin, Miles Paget, and Gabriel Spalding actually filmed it, using a clever trick where a partner photon announces the arrival of each single photon so that a camera can be triggered to catch it, and you can watch, in their footage, the interference pattern of single photons assembling itself one speck at a time. Light does exactly what electrons do, down to the smallest detail, and this is the answer to an objection that people raise constantly, one that sounds sophisticated and is worth taking apart. When you do the double-slit experiment with ordinary bright light and see the stripes, some people will point out correctly that this is just classical optics, ordinary wave behavior that we have understood since Thomas Young 200 years ago, nothing quantum about it at all. And from there they conclude that the light version of the experiment is irrelevant to the real quantum mysteries, that it only shows the boring old fact that light is a wave. But that conclusion is exactly wrong, and the single photon version is why. Because when you turn the light down to single photons and you still get the interference pattern, built one whole unit at a time, you're seeing something that is not classical at all. You're seeing individual, indivisible, countable packets of light, each one arriving whole at a single point, and yet collectively guided into an interference pattern by a wave that went through both slits. That is the full quantum strangeness, the same strangeness as the electron present in light. The bright light experiment and the single photon experiment are the same experiment, just at different intensities, and the single photon version proves that the wave and the whole unit arrival are both there in light, exactly as they are in matter. So the light is not the boring classical case that has nothing to teach us. The light is running the identical quantum program as the electron, and we know it because we can turn it down until the individual quantum arrivals show themselves one speck at a time. Light and matter are not 2 different stories, one classical and one quantum. They are one story. Let me put you in that darkened room one more time because I want you to see it happen. Imagine you're standing in front of the screen with the light at full strength. What you see is a soft, even glow of stripes, the familiar bright and dark bands, looking for all the world like a smooth, continuous pattern painted by a wave. Now begin turning it down. Slide a filter into the beam and the glow dims. Add another, and the whole pattern fades toward darkness. But as it fades, something eerie surfaces out of the smoothness. The even glow begins to break apart into grains. Individual points of light start to appear, one at a time, flick, flick, out of the dark, each one landing at a single sharp spot on the screen. They look for all the world like tiny bullets arriving. But watch where they fall. They never fall randomly. They fall more often in the bright lanes and almost never in the dark bands, slowly stacking up speck by speck into the very same striped pattern that was glowing there when the light was bright. And the realization should settle over you quietly, like the dark settling into the room. The dots were always there. They were always there, hidden inside the glow, arriving by the billion every second, blurred into what looked like a smooth, continuous wave. Turning the light down did not create particles. It only slowed the wave's arrivals until, at last, you could see the dark between them and count the light one photon at a time. Every screen you have ever looked at has been doing this. Every glowing phone, every television, every lamp, every star in the night sky has been firing these whole units of light at your eyes by the trillion, so many and so fast that they blur into steady light, and you never suspect that it is arriving in countable pieces. The particles of light were never little bullets flying through the dark. They were the moments a wave of light was measured, on a screen or on the back of your own eye. And now the 2 halves of the night have come together, and something that sounded like a harmless request, do the experiment one photon at a time, turns out to hide a confusion that runs all the way to the bottom of what light even is. Because if there are no photons until the light is measured, then what exactly did we mean when we asked to send them through the slits, one at a time? Let's take that innocent phrase apart because inside it is the last and deepest correction of the whole story. Part 10. There were never any photons. Let's ask, very carefully, what people actually mean when they say they want to do the double-slit experiment one photon at a time. How would you even set that up? The recipe is simple enough. You take your light source and you turn it down, way down, with filters, until only a very few photons are coming through. Let's say only a handful every second. Now here is the clever part of the reasoning. Light travels fast, unimaginably fast, so it takes only a tiny fraction of a second for any light to cross the entire apparatus, from the source, through the slits, to the screen. So if photons are only being emitted a few times a second, but each one crosses the whole apparatus in a millionth of a second or less, then the chance of two photons being in the apparatus at the same time is almost nothing. On average, at any given instant there is at most one photon somewhere between the source and the screen. And so, people say, this is a one photon at a time experiment. Each photon crosses alone, hits the screen alone, and cannot possibly be interfering with any other photon, because there is no other photon anywhere near it, and yet the interference pattern still builds up, so each photon must be interfering with itself. Now, the conclusion is correct. Each photon really does interfere with itself, exactly as each electron does. But the language, one photon at a time, is quietly misleading, and untangling it is the last piece of the whole picture. Because that phrase makes you imagine a little ball of light leaving the source, travelling across the apparatus like a tiny glowing bullet, passing through a slit and hitting the screen. It makes you picture the photon as a thing that exists during the journey, a particle in flight. But that is exactly the picture we have spent all night dismantling. There is no little ball of light travelling across the apparatus. There is a wave, a faint wave, spreading out from the source, passing through both slits, interfering with itself, and arriving at the screen, where it is measured and delivers one whole unit of light energy, one photon, at one spot. The photon is the arrival. The photon is the measurement. There was no photon crossing the apparatus, because there was nothing whole and countable in flight, only a spread-out wave. The photon comes into being at the screen when the wave is measured, and not 1 instant before. So what does one photon at a time really mean, stated honestly? It means that the light wave has been turned down so faint that, in the time it takes the wave to cross the apparatus, on average only one whole unit of light energy will be delivered at the screen. It does not mean a single ball of light is making the trip. It means the wave is so weak that its arrivals, the whole units it delivers when measured, are spaced far apart in time. The one photon is not a thing that travelled. It is a thing that arrived, and the wave that produced it went through both slits, spread out and interfered with itself, exactly like a wave, because it was a wave, all the way from the source to the instant of measurement. To call it a photon in flight is to smuggle the particle back into the journey, where it never belonged. I know this is subtle, so let me say it in the plainest way I can. For both electrons and for light, the same thing is true, and it is the whole truth of this experiment in one sentence. They travel as waves. They arrive as whole units. The wave is what does the travelling, the spreading, the going through both slits, the interfering. The particle, the whole countable unit, the electron or the photon, is what you get at the moment of measurement, the moment of arrival, and never before. There is no particle making the journey. There is a wave making the journey and a particle-shaped arrival at the end of it. The word electron and the word photon, when we use them to mean a little ball flying through the slits, are describing something that does not exist. What exists is the wave and the countable lump it hands over when it is finally caught. Let me gather up everything we have, because we have come a long way in the dark and it is worth standing still for a moment to see the whole shape of it at once. We started with the lie that watching the double-slit experiment turns waves into particles that land in 2 clumps. We watched a genuine wave make interference stripes and reasoned that a genuine particle would make 2 clumps, giving us a clean test. We fired electrons, sure they were particles, and watched them build the wave's stripes, one lonely dot at a time, each electron somehow going through both slits and interfering with itself. We tried to catch them in the act with detectors, and found that measurement always gives one definite slit and genuinely collapses the superposition, which is true. And then, at the exact moment the story promised 2 clumps, we found instead the single slit interference pattern, still a wave, because measurement did not turn the wave into a particle. It only narrowed the wave from 2 slits to 1. We learned that the wave is what travels, always, and the particle is only the whole unit delivered at the screen when the wave's position is measured. And then we found that light, which we were sure was the simple case, does exactly the same thing, arriving in whole units that were always hidden inside its glow, so that one photon at a time never meant a ball in flight, but only a wave so faint its arrivals came one by one. And notice what has happened to that phrase, catch it in the act, the confident plan we set out with. We were going to catch the electron in the act of going through both slits at once. We were going to catch it red-handed doing the impossible, but there was never anything to catch in flight, because there was never a particle in flight, only a wave. The only thing you can ever catch, the only thing that is ever a definite countable object at a definite place, is the arrival at the wall, the measurement, the whole unit delivered at the end. There was nothing to catch until the wall. The particle we set out to catch in the act never existed during the act. It only ever existed at the moment we stopped the act and looked. The whole detective story was chasing a suspect who does not appear until the case is already closed. There is an image that might help all of this settle, and it comes from something you already know. Think about a rainbow. A rainbow looks like a real object, an arc hanging in the sky at a definite place, and yet if you walk toward it, there is nothing there, and 2 people standing in different spots see different rainbows made of different raindrops. Because a rainbow is not a thing sitting in the sky. It is what happens when sunlight, water droplets, and your particular eye come together in a particular geometry. The rainbow exists at the meeting of the light and the observer, not out there on its own. The particle, the electron or the photon as a definite little object at a definite place, is a bit like that. It is not a thing that exists out in the apparatus during the flight, waiting to be seen. It is what happens at the meeting, the moment the wave is measured, the moment the possibility touches the screen. Before that meeting, there is no particle out there, only the wave, the way there is no rainbow out there, only sunlight and rain. We keep looking for the little ball in the middle of its journey, and being puzzled that we cannot find it going through one slit or the other, for the same reason a child is puzzled that they cannot reach the end of the rainbow. We are looking for a thing at a place, when what is really there is a relationship that only produces a definite thing at the moment of measurement. Hold that, because it takes the last of the mystery out of the word collapse. Nothing collapses in the sense of falling apart. A wave of possibility simply meets a measurement, and at that meeting, and only there, one definite whole arrival comes into being, the way a rainbow comes into being only where the light meets an eye. So the wave is not a metaphor, and the particle is not the thing in flight, and this is true for the matter you are made of and the light you see by, in exactly the same way. But I have been telling you all night that the fringes vanish when you watch the slits, that measurement collapses the 2-slit wave into a 1-slit wave. And there is one more experiment, maybe the eeriest of all, that tells us something crucial about what that watching really is. Because you might still be thinking that the reason watching changes things is simply that the detectors physically bump the delicate electrons, knock them around, jostle the wave apart with their clumsy poking. It is a reasonable thought. It is also wrong, and the experiment that proves it wrong is one of the strangest things human beings have ever done. It is called the quantum eraser, and it shows that what matters is not whether you disturb the particle. What matters is whether the universe knows. Part 11. The same program. Let's take seriously the idea that watching the slits destroys the fine 2-slit stripes simply because the detector physically disturbs the electron. It sounds sensible. To detect which slit an electron went through, you have to interact with it somehow, bounce something off it, and maybe that interaction is just a clumsy shove that scrambles the delicate wave and washes out the interference. If that were the whole story, then the observer effect would be nothing mysterious at all, just the unavoidable clumsiness of poking at something very small. For a long time, that is how many people explained it, and it is still how a lot of textbooks explain it. But it is not right, and the way we know it is not right is one of the most beautiful experiments in all of physics. The experiment is called the quantum eraser, and here is the heart of it. Physicists found ways to label which slit a particle goes through very gently, by tagging it, marking it, so that the which path information is recorded, but without giving it any violent shove that would scramble its path. And when they mark the paths this way, the 2-slit interference stripes vanish, exactly as before, even though the particle was barely disturbed at all. So it is not about the shove. Just having the witch path information recorded somewhere is enough to kill the interference. But now comes the astonishing part. They found that they could then erase that information, throw it away, scramble the record before anyone ever read it, so that it became impossible even in principle to know which slit the particle had gone through. And when they erased the information, the interference pattern came back. The stripes returned. Even though the particle had been tagged, had been watched, the moment the record of its path was erased, it went back to behaving like a wave through both slits. Let that sink in, because it overturns the disturbance explanation completely. What controls whether you get the wave pattern or not is not whether the particle was physically bumped. It is whether the information about which slit it took exists anywhere in the universe. If the witch path information exists, if the universe holds a record of the path, the fine interference is gone. If that information is erased, if no record survives and it becomes impossible to know the path, the interference returns. The pattern responds not to a physical shove but to the existence or non-existence of knowledge. This is not about disturbing the electron. It is about whether the universe in some sense knows which way it went. This idea was proposed by physicists Marlon Scully and Kai Druhl in the early 1980s, and it has been carried out in various beautiful forms since, including a famous version around the year 2000 led by a physicist named Yoon-Ho Kim. And a beautifully simple version can be done with light using nothing more than polarizing filters, the same kind of filters in polarized sunglasses, to tag and then untag the two paths. And here, at last, the two halves of this whole night snap together into a single picture, because of one more fact that I find genuinely astonishing. The exact same eraser experiment can be run on electrons, using not polarization, but the electron's own internal property called spin, and the mathematics is identical. Whether you tag the path of a photon of light using its polarization, or tag the path of an electron using its spin, and then erase the tag, the interference comes back in precisely the same way, described by precisely the same equations. Light and matter are not merely similar in the double-slit experiment, they are running the same program, the same underlying mathematics, the same wave, the same collapse on measurement, the same countable arrival, the same response to information rather than disturbance. Point for point, line for line, the electron and the photon do the identical thing, and that identity, not any drama about consciousness or observation, is the true and lasting lesson of the double-slit experiment. So let's finally say clearly what watching and observation actually mean, because these are the words the lie leaned on, and now we can strip them of their false magic. In quantum mechanics, an observation or a measurement does not require an eye or a mind or a conscious being paying attention. It requires only that the witch path information gets recorded somewhere, that it leaks out into the wider world in a way that cannot be reversed, whether that is into a detector, or a stray molecule of air that the electron bumped, or a single photon that bounced off it and flew away carrying the news. The instant the information about the path escapes into the environment and becomes part of the sprawling tangle of the world, the delicate two-slit interference can no longer form, because the two possibilities can no longer cleanly recombine. Physicists call this process decoherence, and it happens whether or not any person ever looks at the readout. A double-slit apparatus sealed inside a box, with a witch path detector switched on, and no living thing anywhere near it, loses its fine fringes just the same because the universe already holds the record. The detector is not special because someone reads it. It is special because it lets the secret out. And this is why the sealed box matters so much as a picture, so let me make it vivid. Imagine the entire double-slit apparatus, source and slits and screen, and a witch path detector, sealed inside a closed box, in a locked and empty room, with no living thing anywhere in the building. The detector is switched on, quietly recording which slit each electron takes, writing that record into its own machinery, but no one is watching. No one will ever watch. The readout scrolls past into an empty room. What does the screen inside the box do? It builds the single slit pattern, the watched pattern, the one without the fine two-slit fringes. It does this in the dark, with no observer, because the information about the path exists, recorded in the detector, entangled with the wider world, whether or not any mind ever learns it. The universe does not wait for a human to read the readout. The moment the path information becomes part of the physical record of the world, the fine interference is gone. Now imagine instead that the detector is switched off, and the same box sits in the same empty room. Now nothing records the path, the information never escapes, and the screen inside builds the full two-slit interference pattern, the fringes bright and complete, again with no one watching. The difference between the two boxes is not a mind, it is not a gaze, it is nothing but whether a record of the path exists in the world. That is the whole of the observer effect, stripped of every trace of magic. It was never about consciousness or attention or the power of looking. It was always about information, about whether the universe holds a record, in a detector, in a scattered photon, in a jostled molecule of air, of which way the thing went. The empty box behaves exactly as the watched one does, because the universe was never performing for us. It was only ever responding to what it itself records. This matters more than almost anything else in the whole story, because of what people have done with the alternative. The most popular fringe reading of the double-slit experiment is that it proves consciousness creates reality, that because observation collapses the wave, and observation means a conscious mind, the universe only becomes definite when an aware being looks at it. This idea has a real history. The great mathematician John von Neumann noted that the equations do not by themselves say exactly where along the chain of detectors and eyes and brains the collapse happens, and a physicist named Eugene Wigner speculated for a while, in the middle of the last century, that maybe consciousness was what completed it. It is not a stupid idea, and it was taken seriously by serious people. But it is a minority view that almost no working physicist holds today, for the simple reason we just met. Decoherence shows that the path information escapes into the environment and destroys the fine interference long before any conscious observer enters the picture, in a sealed box with nobody watching. Observation was never shorthand for a mind. The mystical version survives not because the evidence supports it, but because it flatters us. It puts human awareness at the center of the cosmos, hands us the power to conjure reality by looking. And the honest wonder of this experiment does not need that flattery. It is larger without it. You do not create the interference pattern by looking. The universe was making that pattern out of every electron and every photon, long before there were any eyes to see it. I should be fair, though, and tell you that there are serious, respectable alternatives to the standard story, because physics has not fully settled what the deepest reading of all this is, and it would be its own kind of lie to pretend otherwise. There is a beautiful minority interpretation called the pilot wave theory, first sketched by Louis de Broglie, the same man who predicted matter waves, and revived decades later by a physicist named David Bohm. In the pilot wave picture, the electron really is a particle, with a definite position and a real path at every instant, but it is carried along by a physically real wave that spreads through both slits and steers it. On this view, each electron does go through exactly one slit, as a genuine point particle, and yet the wave that passes through both slits pushes it into the interference pattern anyway. It reproduces every single result of the double-slit experiment perfectly, including the single-slit pattern under measurement, with no collapse and no mysticism at all. Its price is that the guiding wave has to respond instantly to distant conditions, a kind of built-in connection across space that most physicists find harder to swallow than the standard account. But here is the thing I want you to notice, and it is almost funny. Even in this theory, the one respectable interpretation where the electron truly is a particle taking one definite path, the wave through both slits is still real, still there, still in charge. There is no version of this experiment, none, in any serious theory, where the wave can be thrown away and the two clumps come back. And there is another serious view, called the many worlds interpretation, proposed by a physicist named Hugh Everett in the 1950s, in which the wave never collapses at all. Instead, every possible outcome actually happens, each in its own branch of reality, and the single dot you see is simply the branch you happen to find yourself in. It is a genuine position held by genuine physicists, and it dissolves the mystery of collapse by refusing to make measurement special in the first place. I am not going to tell you which of these is right, because nobody knows, and anyone who tells you they are certain is selling something. But here is the reassuring and slightly comic point of surveying all of them. Across every mainstream interpretation, and every serious minority one, from the standard collapse picture to the pilot wave to the many worlds, not a single one of them predicts that watching turns the electron into two clumps of classical bullets. The popular myth is not the position of any school of quantum thought. It belongs to none of them. It is a story that escaped from the classroom, lost its footnotes along the way, and went feral, believed by nearly everyone precisely because it belongs to no one. And that leaves us, at the end of the long dark, with the one thing all of this has been quietly building toward, the real lesson, the thing the lie was invented to hide. It is time to say plainly what the double slit experiment actually reveals about reality. Part 12. Neither, and what that means. Here is the real lesson, the whole of it, in the simplest words I can find. Electrons, which we were completely certain are particles, and light, which we were completely certain is a wave, do the exact same thing in the exact same experiment described by the exact same mathematics. And neither of them is fully a particle, and neither of them is fully a wave. Each one is a single kind of thing that travels as a spread-out wave of possibility, and arrives, when measured, as one whole countable unit. That is what an electron is. That is what a photon is. They are not two different kinds of thing, one wavy and one bullet-like, that happen to behave similarly. They are the same kind of thing, and it is a kind of thing we do not have a good word for, because it is not a wave, and it is not a particle. It is something else, something more fundamental, that can wear either mask depending on which question we ask it. Think about how strange and how quiet that is. We spent this whole night asking, is the electron a wave or a particle? Is light a wave or a particle? And the answer the universe keeps giving us is yes and no, and you are asking the wrong question. Because wave and particle are not two natures that these things flip between. They are two shadows that one single thing casts on the walls of our imagination, and our imagination was built by a world of pebbles and ponds, of solid things you can hold and ripples you can watch, and it only has those two shapes to offer. When we send that one underlying thing through the slits and let it travel, it casts the shadow of a wave, spreading and interfering. When we catch it at the screen and ask where it is, it casts the shadow of a particle, one whole unit at one point, same object, two shadows. And we, staring at the shadows, invented two whole categories and spent centuries arguing about which one was real, when neither of them was ever the thing itself. And now look back at the two clumps, the piles behind the two slits, the ghost we have carried with us since the beginning of the night. They were never going to appear. Do you feel now why? The two clumps were the prediction of the particle picture, the picture that says the electron is a little bullet that goes through one slit and flies straight to the screen. But there is no little bullet. There never was. There is only the wave, and the whole unit it delivers when it is measured. So there was never any mechanism that could make the two clumps, watched or unwatched, because the two clumps require a particle in flight, and there is no particle in flight. The two clumps are the ghost of a picture of reality that was wrong from the start. Every explanation that promised them was promising you the visible proof of a bullet that does not exist. They are the single most important thing that never happens in this experiment, and their absence is the whole truth of it. And the little bullets themselves, the tiny balls we imagined, the electrons as marbles and the photons as glowing pellets, they were never there either. Not through the left slit, not through the right slit, not watched, not unwatched. There is no moment in the entire experiment, from the source to the screen, when there is a little bullet flying through space. There is a wave that travels, and a whole unit that arrives, and the bullet was a picture we laid over the top of it because bullets are the only small solid things our imaginations know. Neither the electron nor the photon was ever a bullet. The matter you're made of and the light you see by both turn out to be the same not quite thing, the same wave that arrives in units, the same shadow-casting mystery, and the little balls were never anything but our own intuition, painted onto a reality that never contained them. I want you to feel what that does to the oldest division you draw in the world, maybe without ever noticing you draw it. You separate matter from light. You separate the solid stuff, your body, the chair, the ground, from the glow, the light, the radiance that lets you see. Stuff over here, light over there. Two utterly different kinds of thing, and the double-slit experiment, read correctly, quietly tells you that at the very bottom, that division softens. The electrons in your hand and the photons leaving your screen are doing the same profound thing in the same way, waves in flight and whole units on arrival, running the identical program down to the last line of mathematics. The matter of your body and the light in your eyes are, at the deepest level we can probe, the same kind of strangeness. And that is not a loss. It is a strange and quiet kind of kinship. You're not solid stuff looking out at alien light. You're made of the same wave that arrives in units that the starlight is made of, the same thing, wearing different masks. When you look up at the night sky, the photons landing on your eye and the electrons registering them in your retina are at bottom one family. Now I have to be honest with you, the way I promised at the start I would be, because there is a real mystery left standing here, and it would be its own kind of lie to tidy it away. We have cleared out the fake mystery, the one about observation and consciousness and changing reality. But underneath it, we have uncovered a real one, and it is deeper than the fake one ever was. It is this. Why does measuring the position of a spread-out wave force it to appear, whole and indivisible, at a single random point? The wave itself evolves smoothly and predictably. As long as nothing measures it, everything follows clean, exact equations, the interference, the superposition, the passage through both slits, all of it perfectly determined and understood. But the instant a measurement happens, the smooth wave delivers a single dot, and only the odds of where were ever knowable, never the exact spot. Nothing in the equations explains how or why the spread-out wave of possibility becomes one definite fact. This is called the measurement problem, and after 100 years of the most brilliant minds our species has produced, it remains genuinely, honestly unsolved. It is the real crack in the foundation, and the pilot wave and the many worlds and all the rest are rival attempts to fill it, and none of them has won. So the true double-slit experiment does not hand you the tidy thrill the lie promised. It does not tell you that reality obeys your gaze, that looking is power, that the universe performs for an audience. It hands you something better and more honest, and I think more beautiful. It tells you that the universe, at its finest grain, is built out of things that are neither waves nor particles but something we are still learning how to name, things that travel as spread-out possibility and arrive as single facts, and that the moment of arrival, the moment of measurement, is something no one on Earth yet fully understands. The lie was comforting because it made looking feel powerful, and it let you keep your two familiar boxes, wave and particle, intact. The truth is stranger and quieter, and asks more of you. It asks you to give up the boxes. It asks you to sit with a mystery that is genuinely open, and it gives you in return a universe that is doing something extraordinary in every atom of your body and every ray of light in the sky, all the time, whether or not anyone is watching, whether or not there are any eyes in the cosmos at all. Because that is the last thing, the thing to carry with you as you drift off tonight. The lie put you at the center, made the universe wait for your gaze before it decided how to behave. The truth takes you out of the center, and strangely, that is the more wonderful place to be. The electrons were going through both slits and interfering with themselves for billions of years before there was a single eye on this planet to watch them. The photons were arriving in whole units, painting their patterns of light and dark, when the Earth was molten and the sky had no one under it. The universe never needed you to look. It has been doing this same impossible, beautiful thing since long before there was anyone to be amazed by it, and it will go on doing it long after. You're not the one who makes it real by watching. You're one of the ways it has, briefly, come to be able to watch itself. So the next time someone leans in with the wonderful, thrilling, mysterious story, the one about how the double-slit experiment proves that observation changes reality, that watching turns the waves into particles, that your gaze collapses possibility into solid fact, you will know. You will know the two clumps never come. You will know the wave never stops being a wave. You will know that the electron and the photon are the same quiet strangeness, wave in flight and whole unit on arrival, and that the particle was only ever the shape of the moment they were caught. And you will know the real question the experiment leaves open, the one worth staying up for, which is not whether looking changes reality, but why the spread-out wave, when it is finally asked where it is, answers with a single point. That is what actually happens when you look. Not two clumps, not a wave turning into a bullet, just a wave of possibility spread across the dark being asked one simple question, and gathering itself, out of everywhere it might have been, into a single point of light on the glass. Rest well.